examine materials at the surface and on the way down to see if there's comparisons. We'll learn how important it is to where we have to refine our analyses, where we'll understand the preservation issue and how it affects things at the surface as compared to things further down. But most importantly, if there are biosignatures inside that organic material or associated with it, we're going to have a better chance of understanding that if we get to materials that are not exposed to all this radiation.
That's one of the things today. We're finding some very interesting chemistry right up on the surface of Mars, and it's a promise of even more interesting chemistry to come if we can get a little bit deeper down underneath that. So, we're looking at Gale Crater, so how did these organics get here? I mean, we're finding these organic molecules now on the floor of Gale Crater. How'd they get there?
So what we're looking at here are a lot of layers that were put down in an ancient lake. And as previously we discussed, that lake had been there for a long period of time, hundreds of thousands, maybe even millions of years, we're not sure. But those lake sediments are for a gigantic lake. Organic materials can come into that lake through rivers. They could be wind-blown in, or they can be formed in the actual lake itself by things like biology. Now, there's 3 different sources of organic materials, too. One of them is the biology. One of them could be meteorites that are infalling into the surface and being directly deposited. And the other one is a rock-forming processes that might generate organic material all on their own, and they might be the ones that are being brought in by rivers. We don't have enough information from the observations we've made to tell what the source is and how it got in there.
So we found this really good location to look for organics on Mars, and we're also going to talk now about the seasonal methane. So, I mean, are your discoveries about the sorts of organics and the site, is that all related to Chris's stuff about the seasonality of methane?
Yes and no. If you take the organic detection in the ancient rocks, and you just generalize it, we have found organic material in the subsurface. And that might be representative of organic material throughout a grander area. And that is carbon that could go through various processes and make its way to the surface and turn into things like methane and then seep into the atmosphere. Now, the detection that Chris is going to talk about is about modern-day methane, as opposed to ancient signals, what I discovered in the rocks.
All right, so with that, we're going to go over to Chris Webster back at JPL. And so Chris, tell me a bit about the seasonality of methane. Give us some detail about this new discovery.
Well, I thought I'd tell you right away that we've seen the seasonal variation, and we've tried to look at the data and come up with some explanations. And we've been able to rule out some of the sources. We don't actually think the meteoritic or delivery of interplanetary dust that can produce methane in the atmosphere, as Jen said, we don't think that's so important because we wouldn't expect to see a large seasonal variation. We might see 20%. Instead, we're seeing this massive change in the methane signal. And so what we consider, we look at the data, and the idea that best fits our data is the idea of subsurface storage. So way under the ground, under Mars, there's methane that's trapped. It may be trapped as clathrates or other materials. We don't know if that methane is ancient. We don't know if it's modern. It could be either. And we also don't know if that methane was created from water rock chemistry like serpentinization, or it was created by methanogen microbes. We cannot distinguish that. But the methane leaks or seeps up to the surface, we believe, and finds its way through cracks and fissures. And eventually, when it gets to the surface, we're then in a situation where the surface temperature can modulate or especially amplify the release of methane. So this is an exciting time because we have this seasonal cycle to constrain some of the theories and of the sources and sinks of this important gas.
Now, Chris, I want to talk to you a bit more about trying to distinguish between whether this is a biological or non-biological source of the methane. But to begin with, tell us about how you actually detected this. So in the case of Jen's work, they actually brought Martian soil into this oven and heated it up. But how was the methane variation detected?
Well, it's we're ingesting from the air, and if you look at Curiosity, around about waist height, there are 2 inlets, 2 little valves, and these valves allow the Martian atmosphere into our sample cell. Once it gets